The next topic in electromagnetism is we're going to take our long straight wire and we're going to bend them into coils. The issue is, I've been talking about engineers. As engineers and people started to build things, what they noticed is that the magnetic field we get from a long straight wire isn't actually very strong. If you ever played around with it and tried to pick up paper clips, you wouldn't pick up many paper clips with a wire or with electricity in a long straight wire. Um, the applications of this, like when they show like junkyards and electromagnets picking up old junk cars and carrying them and then dropping them, you would never be able to pick up a car with a magnetic field from a long straight wire. It's just not strong enough. But if we take that long straight wire and we wrap it into a coil shape, the coil actually amplifies the magnetic field that we get inside the coil, so much, much stronger. And then as well as that, if we, instead of the coil being around air, if we wrap the coil around a metallic core, some sort of metal material, the metal also amplifies the magnetic field. So kind of the classic is maybe if you're an ESQ or a different STEM-based summer camp or PD day activity, just take wire, wrap it around a nail and connect that to a battery. That'll turn the nail into an electromagnet, and it's a stronger electromagnet than what we'd get from just a plain old long straight wire. We use things like this in motors and speakers. If we tried to make a speaker with long straight wires instead of coils, the speaker wouldn't have a lot of, it wouldn't be very loud. It wouldn't move much. We wouldn't be creating much of an effect from the electromagnetism. It would be virtually impossible to make an electric motor unless we used coiled wires instead of long straight wires. So coiled wires amplify the magnetic field, make the magnetic field stronger. Therefore, we need to understand those because they're in applications, they're more important than straight wires. Luckily, we've got a left-hand, right-hand rule to describe the direction of the magnetic field that we get inside the coils. Good news or bad news, it's the same shape of hand as the last one. So hopefully it doesn't confuse you. Last one was for long straight wire, we did a hitchhiker hand. And since your thumb was straight, your thumb matched the wire. This time we're still going to make a hitchhiker hand, but now your curly fingers match the direction of the circle that the current is going in. The current's going around this coil in circles. So have your curly fingers match the circle of the current, and then your thumb, your straight thumb, matches the magnetic field that's inside that coil. And then similar to what we did before, positive flow we'll use right hand, negative flow we'll use left hand. That's the rule in words. I'll talk you through a couple examples, and then there's a bunch for you to try. Okay, I'm going to go this far. A current is flowing through a coil. So we know as soon as you hear coil, that tells you hitchhiker hand for the shape of your hand. From your perspective, positive flow. So that tells you which hand. And it's going in clockwise circles. That either tells you something about your fingers or your thumb. What is a magnetic field? Then it asks about the other, fingers or thumb. Whatever we know, we're asked for the other. Think about it on your own. Positive flow means right hand. So take your right hand, make the hitchhiker hand. Now orient your right hand so that when you look at your fingers are clockwise. Then the question wants to know when your right hand, when you look at it, so your fingers are clockwise, what's the direction of your thumb? I'm going to put my pen down to check it. I need my fingers going clockwise. It's kind of awkward on my wrist when I get that going correctly. My thumb is pointing away. If I had to draw it away from me, so I imagine like an archery arrow flying away from me, I would see an X from the tail feathers. Okay, scrolling down so you can see, unless you could have peeked ahead, but here's my typed up answer. I'm using my right hand. I've got to curl those fingers to match the clockwise, which means they're curling around that way. When I do that, my thumb is pointing away from me, but away from me is tricky to draw on 2D paper, so we're going to draw it as an X. If I were to type it on a test or an assignment, I would kind of type it like this, or draw it on a computer, kind of like that. Then I'd have to add some words. The arrow is the positive flow. Let's try another one together. Oops. Yep, we're okay here. I started answering this. Let's get rid of those. For this one, I didn't draw a battery. I'm telling you, so it's a coil, so you know hitchhiker hand. I'm telling you the negatives go up and into the coil when they're on the left and down and out of the coil on the right. So my negatives are going up this wire and then looping around. And by the time they get way over here, they're coming down and out. So up. I'll let you pause of this before I talk too much. Think this one through, see if you can figure that out. I'm telling you negative flow, so what does that mean? Hitchhiker, so far both our rules are hitchhiker. Negative flow, so left hand. Now this is a little bit, I don't know, maybe it bothers some people to see this, but negative flow is kind of going towards the ceiling when it's farther away from us and down when it's close to us. So with your left hand, hitchhiker hand, make it so that your fingernails are pointed towards the floor when they're close to you. When you do that, you're going to get that your thumb is pointed to the left. So the answer is thumb pointed to the left, or the magnetic field is to the left. Here's my typed up with diagrams. Based on the coil, the electrons are coming down when they're close to us, so my fingernails when they're close are going down. And I get the answer that my thumb is pointed to the left. If I were to type this one or write it out on the computer, that's how I would show the coil. I'd have to use words, or I could draw a battery to give you an idea of the positive flow. Oop, there's a bit of typo here. I didn't catch that before. I'll switch it on your document, so hopefully it's fixed when you look at the document. This was a question about negative flow. One more example, then I'm going to turn you loose. This time I've given you the battery. By giving you the battery, you can determine if you want to do left-hand rule or right-hand rule. Remember what we know about a battery? If we were to do it negative flow, we'd have to use our left hand. Negative charges would leave the little side of the battery. If we were to do conventional or positive flow, positives leave the big side of the battery. I honestly can't remember how we typed it, so I'm going to do negative flow first. If I did negative flow, negatives would leave the little side of the battery, go down here, and when they get to this important coil, they're moving from right to left and kind of tucking away from us when they're on the left. And popping out on the right, moving from right to left. So hitchhiker hand because it's a coil, left hand because it's negative. Now orient your left hand so that your fingernails, when they're close to you, are pointed to the left. So we got a left, a lot of lefts. Left hand rule. Hitchhiker hand with your fingernails pointing left. However, if you see it a different way, that's okay, as long as you kind of agree with the picture I'm about to show. Hopefully my picture's left-hand rule. Yeah, we got lucky. When I typed it, I did negative rule, negative hand first. So for negative flow, left hand kind of looks like that, and your thumb is pointed up. So the answer is the magnetic field is upward through that coil. If we did it with positive flow, here, let's get rid of all this. If we did it with positive flow, the positives would leave the big side of the battery and go upward. When they get to this coil thing, they tuck behind it, and when they're close to you, they're going from left to right. So with your right hand, orient your right hand, hitchhiker hand, so that your fingers are pointed when they're close to you, they're pointed to the right. Scroll down, that means your right hand would look like that. But notice we get the exact same answer. Your thumb is still pointed up. So the answer is still pointed up. That's the cool thing about the left hand, right hand rule. When you do, you could do either one, and as long as you do it correctly, we're going to agree on the final answer. That's where we'll pause this. If you scroll down, there is a worksheet to practice these two left hand, right hand rules, but we have one more left hand, right hand rule to get through. You're welcome to jump ahead and look at the worksheet and then backtrack, or power through the last left hand, right hand rule and then do the worksheet. As always, email if anything's bugging.